So electroencephalogram. So this is nothing but this is the record, uh, which will record the bioelectric potential generated in the nerves of brain. Okay, neuron. So brain nerve will be called as neuron. So neuronal activity will be measured by the bioelectric potential will be called as the electroencephalogram. So these are the EEG sample waveforms. So while you are awake, okay, with mental activity, that means you are when you are brisk, when you are doing some activities, okay. So the signal will be looking like this. The frequency will be nearly in the range of 14 to 30. The frequency will be very high, okay. See, the waveform will be very close to each other. That means the frequency is very close. That is high. Okay. Frequency range will be very high. So 14 to 30 range will be called as beta range. Okay. In the EEG waveform, you will determine the range of hertz frequency. That is 14 to 30 hertz as beta. And then while you are waking but you are keep on resting, that means you are sitting or you are lying on bed but you are awake, okay, you are not sleeping, okay, you are not doing any activities but you are taking rest but you are in conscious mind, okay. At that time you will be having the EEG signal like this, okay. So the range of frequency will be somewhat decreasing from the activity signal, okay, while you are inactive, while you are doing something, some other work, okay. So your brain is doing some work, okay. At that time you will be having this waveform, but while you are in rest you will be having this waveform. So the frequency range will be reduced from high range, that is 8 to 13. In the range la it will be, that will be called as alpha waveform. And then sleeping mode, okay, while you are sleeping you'll be getting like this waveform. See, look at this, here the frequencies are decreasing more than your active work, okay. So here the waveforms are very close to each other, but here it's apart, okay, to each other. So this will be in the range of 4 to 7 hertz. This waveform will be called as theta waveform. And then deep sleeping, okay, அடிச்சு போட்ட மாதிரி தூங்குறாங்க அப்படிங்கிறாங்கள, in that sleep you'll be having more frequencies, okay, sorry, less frequency, okay. High frequency is while you are awaking, less frequency will be in the deep sleep, that is less than 3.5 hertz. That waveform will be called as the delta. So see the amplitude level of the waveform. So here you will have low amplitude by the high frequency, here somewhat high amplitude but low frequency. Here amplitude value increasing than the alpha waveform, but frequency value is decreasing. Here low, very low frequency, but amplitude is very high compared to other waveform, okay. So your frequency and amplitude will be increasing and decreasing based on the activity, brain activity, okay. So these, all these activities based on your brain activation, okay. So the same point is given here. An alert wide awake person, okay, usually displays an unsynchronized high frequency EEG signal, okay. So the awakened person, that is nothing but your brain doing some work. That time you will be getting the high frequency waveform. And then drowsy, when you are feeling drowsy, you are not doing any other work but still your brain is active. At that time you will be getting rhythmic activity, okay. So that the signal range will be lying between 8 to 13 hertz. So when you are, begin to fall asleep, the amplitude value will be increasing and frequency value will be decreasing, okay. And then in light sleep you will be getting large amplitude, frequency value will be goes on decreasing. In deeper sleep, you will be getting more slower frequency but higher amplitude signal. Okay, so while you are sleeping, you will be having rapid eye movement. Okay, so the eyeball alone will be moving, even though you if you are closing the eyelids. Okay, so eyelids close இருந்தாலும் you will be having the movement of eyeball from here to one end to another end. Okay, so at that time, that is nothing but you are dreaming. Okay, in the deep sleep you are dreaming, that is said to be rapid eye movement. Okay, during the rapid eye movement only you will be having the dream. So at that time, you'll be getting the high frequency waveform, EEG waveform. Okay, so the various frequency range of the EEG waveform are given here. It is below 3.5 hertz. Will be here. The waveform will be called as delta waveform. From the 3.5 hertz to 8 hertz, the waveform will be called as theta. 8 hertz to 13 hertz, alpha waveform, and then above 13 hertz, the waveform will be called as beta waveform. Okay, and then evoked response. So this is nothing but evoked response is nothing but disturbance response. Okay, you're disturbing the brain. You're stimulating by giving external stimulus. Stimulating is nothing but stimulating என்ன? You're you're boosting some point. Okay, that will be called a stimuli. So you are giving stimuli from the externally. Okay, externally you are giving the stimuli to the brain. Okay, like a flash of light you are blinking, then you may give you a click of sound. Okay, any sound, any light, or bringing to the brain knowledge. Okay, that will be called as a disturbance. That is disturbance response will be quite repeatable from the all this disturbance. Okay, uh, it can be easily able to distinguish from the EEG activity. That is, you will be getting normal EEG waveform. You if you are having disturbance like this disturbance, stimulus disturbance from the external part, then you will get the difference in your EEG signal also. This is measured by uh, averaging techniques. Okay, using many averaging techniques. So EEG led system. So even though you are measuring the potential, biopotential from the brain, you are going to use the scalp for placing the electrodes. Okay, in the scalp only you are going to keep the electrodes. Here you are going to use more than 20 electrodes, 10 to 20 electrodes in the human head scalp. Okay, the distance between the each electrode will be 10 to 20 percentage. So this will be the front part of the human being, that is face, uh, frontal, uh, forehead ன்னு சொல்லுவாங்க இல்லையா, the forehead will be called as nasion. Okay, and then back side, back of the head will be called as inion. Okay, nasion, inion. So in between that only you are going to place your electrodes. Okay, and then lobe, left earlobe, and then right earlobe. So in this angle also you will be keeping the electrode. So, International Federation of EEG Society has suggested 10 to 20 electrode placement system for EEG recording. So, in this EEG measurement, you will be having using 10 to 20 electrodes. Okay. So, here what type of electrode will be used means silver or silver chloride electrodes are used for placing on the surface of the head. Okay, that is scalp. So on the scalp, the distance between the two electrode will be 10 percentage or 20 percentage will be the specified distance. So the nasion and inion, I said already, nasion and inion is nothing but frontal part and back part of the head. Okay, frontal part is your forehead, and then back of the head. Okay, so these two will be acting as a reference point, which will be near to the ear lobes of the human being. Okay, ear lobes, I think you all know, ear back of the ear will be called as earlobe. Okay. Over the head, the distance between the nasion and the inion are divided into 5 points. Okay. So from the nasion to inion, you will place the five electrodes. Okay. So the nasion inion distance via the vertex is measured. So distance as well as vertex will be measured. Okay. In this equipment, and three electrodes are placed as one in frontal, one in central, and one in parietal. So one front side and another one be in the center part, and another third one will be in the back side of the head. Okay, so totally three electrodes will be placed from nasion to inion, but you will be having 5 points, but you are going to keep only three electrodes in between that nasion and inion. So that electrodes will be placed at a distance of 10 percentage, 20 percentage, 20 percentage, 20 percentage, and 20 percentage. That is nothing but in between the two electrodes will be having the distance 10 percentage. So at each side 10 percentage means totally you will be having the 20 percentage. Okay, don't get confused that 20 percentage they given, then next 10 percentage given, like that you don't get confused. At each side, that is electrode, each side, both side. Okay, each side means both, only two sides, so left and right. So left and right you will be having 10 percentage each. Okay, so totally 20 percentage, அதுதான் 20 percentage distance ன்னு சொல்றாங்க. Okay, so first diode will not have the two sides, only one side, because it will be moving along one direction. Okay, அதனால தான் அது first diode will have 10 percentage, but last diode also will not have second direction, only one direction will be there, so 10 percentage. So remaining electrodes will have two direction. Okay, two path, so அதனால தான் அது 20 percentage. Okay, now similarly nasion and inion distance is measured along the temporal lobe, and five electrodes are placed as two in frontal, two in temporal, and one in occipital. So two frontal na front side, two, and then temporal side, that is center part, two, and then backside one. Okay, so totally five electrodes will be placed along the temporal lobe. Okay, similar to nasion and inion, you will be having temporal lobe. If you see the picture means you can able to understand. Okay, nasion and inion, இது வந்து left lobe, right ear lobe. So here you will be placing, you will be having the 5 points, 1 2 3 4 5 point, but you are going to have only three electrodes. One second. இப்போ வேணுமா வேணாமா? போய் கார்ட்டூன் பார் போ. போய் எடுத்து போய் பார் போ. இங்க வரக்கூடாது அம்மா கிட்ட. இதுகிட்ட கதவு சத்தல், நான் மறந்துட்டேன் கதவு சத்தல். So in between inion and nasion, you will be placing three electrodes, F2, C2, P2. Okay, so but you will be having 5 points, 1 2 3 4 5. Okay, um, and then temporal lobe have five electrodes. Okay, so 5 points. Temporal lobe has five electrode, so that is nothing but this one. இதுதான் நேசியானா. So nasion near temporal lobe. So F1, F3, F2, F4, F5. So five electrodes are placed. Okay, in this lobe. So they also placed at a distance of first electrode in 10 percentage, second electrode 20 percentage, third 20, fourth electrode 20 percentage, fifth electrode 20 percentage. That is 10 percentage of this length on either side. Okay. So on either side you will be having 10 percentage. So totally 20 percentage. That's all. Then lastly, you will be having the sixth electrode on the peripheries of the circle. That is remaining part. Other than these two setup, you will be having remaining parts. Okay, that in that part you will be placing six electrode, two in front side, two in central, and two in parietal. Okay, see other part you will be placing. இங்க place பண்ணியாச்சு. And then அப்பனா இதுதான் நினைக்கிறேன். Temporalனா இந்த part. Okay, 1 2 3 4 5 because 3 electrodes already we kept. அப்ப இந்த 5 electrode. அப்ப remaining 6 means 1 2 3 4 5 6. Okay, you keep. So you don't want to see the diagram, just you imagine. Okay, then you will not get confusion. If you see diagram means you will get confused. So you just think that other than that two parts, that is pi electrode and 3 electrode, which is kept in the anion to nasion, as well as in the temporal lobe. Okay, the remaining part will have 6 electrode. That's all. Close that point. Okay, so in the setup totally 19 electrodes will be placed on the brain scalp, and one electrode will be acting as a reference electrode, which will be placed near to the ear lobe. Okay, so this system will be known as 10 to 20 EEG system. Okay, because here we are going to use 10 to 20 electrodes. Then this is the EEG recording setup. So on the scalp, you will be placing 10 to 20 electrodes. From the 10 to 20 electrodes, you will be connecting to the 8-channel selector. Okay, through the wire. Okay, so one end of the wire will be having electrode connected to electrode, and the other end will be connected to 8-channel selector. So again, then 8-channel selector will be connected to differential amplifier, where you will be having preamplifier. So the preamplifier and differential amplifier will be used for minimizing the error which is generated in the EEG waveform. Okay, so 8-channel selector usage. What is the usage of 8-channel selector? Means you will be selecting the electrode for measuring the EEG signal, or the point where the biopotential generated will be measured, will be selected by the channel 8-channel selector. Okay, that will be given to the differential amplifier. Here the preamplifier and differential amplifier will reduce the errors present in the EEG waveform, and then it will be given to the filter. Filter means you will be having many filters: low pass filter, high pass filter, and band pass filter. So based on the frequency you are getting in the signal, it will reduce that frequency range by using the particular or absolute filter type. Okay, and then it will be given to the display device for displaying the graph. Okay, or signal. So here the memory will be holding the signal for future use, and then the signal which you are getting from the brain will be given to the signal processing unit. So the signal processing unit will be doing some process. It may be any process. Okay, It may do frequency changes or time changes or time to frequency converter, whatever process will be done in the signal processing unit and produce the output in the output unit. Okay, this will be given as a feedback to the brain itself, that is external stimuli is nothing but one triggering signal will be applied based on this signal processing unit. If your signal is not proper, then you will be giving a feedback through the signal processing unit as a external stimulus. So stimulus having different types, that is audio, visual and tactile. Audio na audio sensing, through the ear you will be able to hear the noise. Okay, visual stimulus means you can able to sense the uh, you can able to see the see the picture, see the movement, anything else. Okay, that is visual stimulus. And the tactile stimulus is nothing but sensation, touching sensation, that will be coming under tactile stimulus. Okay, so these are the stimulus, that is triggering signal provided by the device to the brain. Okay, externally, based on the feedback you are getting from the brain. So here 21 electrode system will be used, that is 10 to 20 electrodes will be used randomly. Electrodes are connected to 8 channel selector. So output from 8 channel connector goes to the differential amplifier bank. The differential amplifier is made of preamplifier that will be used for reducing noise. Then 50 hertz noise is created due to AC interference, that can be reduced using differential amplifier. The output which is obtained from differential amplifier will be connected to the signal processing unit. So any further processing, okay, any processing, particular processing is not indicated here. Any processing can be done in the signal processing unit. So finally it will be, the waveform will be displayed in the display unit. So applications of EEG. So where you are applying this EEG measurement means for diagnosing epilepsy. What is epilepsy? Any one of you? வலிப்பு வலிப்புன்னு சொல்லுவாங்கல்ல, that is epilepsy. Okay, so வலிப்பு and the epilepsy comes because of the brain disorder. Okay, then anesthetic level, anesthetic also based on the brain only. Okay, then brain injury. What is brain injury? Getting damage, brain damage. Okay, and then monitoring during surgery. So these are the applications of EEG. Then EEG measurement. So this system helps to record the potential generated from the sensory parts of the brain. Okay, you can able to record the biosignal from the sensory part of your human brain. And then to achieve this, output unit will be connected to audio stimulus, visual stimulus and touch stimulus. This tactile stimulus. Okay, it can also able to measure the time delay between stimulate and response from the brain. So while you are giving stimulate signal, that is triggering signal from the external mean, but your brain responding time, these two time will be measured, that will produce a delay between these two activities. Okay, that also can be measured by EEG measurement. In addition to that, you can use the filter bank, low pass filter, high pass filter, band pass filter. Okay, which will be removing the noise from brain waves. And then output recording, you will be using either pen or pen recorder or CRO. Okay, for recording. Then three modes will be utilized in the EEG measurement, that is unipolar, average mode and bipolar mode. I think unipolar means one electrode, two electrode will be involved in the measurement. Average mode means either one or two. Okay, these are the three modes of recording, that is EEG recording modes.